harder geometric proofs. So here we're going to look at some examples that involve harder geometric proofs. Let's have a look at a rectangle where this side equals this side and this side equals this side. We have a diagonal where this is 68 degrees and we have x. And we want to solve for x. Well, here we just have a right angled triangle, and in any triangle the sum of all angles is 180 degrees. So we can say that x is going to be 180 minus the 90 degrees in the corner minus the 68 degrees, and x is going to be 22 degrees because angle sum in a triangle is 180 degrees. So we've got to make sure we give reasons for everything we're doing when we do geometric proofs. Let's look at another example. So here we have a quadrilateral with one of the lines extended. This angle is x plus 105. This one in here is 2x plus 55. This one's 115 degrees. And this is a right angle, even though it doesn't look like it. And we want to solve for x. So what we can do, the first thing we can do is say that this angle in here equals, it's on a straight line, so we can say it's 180 minus x plus 105. And now we have a quadrilateral inside here, and we know all of these add up to 360. So we can write up an equation that 180 minus x plus 105. So you notice I put it in a bracket because it's important, because it's 180 minus the entire angle, plus 90, plus 115, plus 2x plus 55, all equals 360. We can say angle sum in a quadrilateral equals 360 degrees for our reason. We just have to go ahead and solve this equation. So we've got, let's just expand our bracket, 180 minus x minus 105 when we expand out the minus, plus 90 plus 115 plus 2x plus 55 equals 360. Let's collect our like terms. So we've got 2x minus x is just going to be x, and all the numbers added together is going to be 335, equaling 360. That's minus 335 from both sides. So x is going to be 25 degrees. Let's have a look at another shape. Okay, we have a shape, this is 140 degrees, this is 120 degrees, another 120, and 90. This one's 3x plus 15. This angle there, and that's 100. Now what kind of shape do we have here? We've got 1, 2, 3, 4, 5, 6 sides, so we've got an irregular hexagon. And what we want to do, we can use our formula for an angle sum of a polygon equals 180 times n minus 2 to work out the angle sum of any polygon. this is a six-sided polygon. So it's going to be 180 times 6 minus 2, which is 180 times 4, which is going to give us 720 degrees. So we know this polygon, all the angles, should add up to 720 degrees. So let's go ahead and write an equation. So we can say that we'll start at the top with the 140. We'll go around clockwise, so 140 plus 120 plus 120 plus 90 plus 3x plus 15 plus 100 should all equal 720. Let's add all our like terms, so there's only a 3x, that's the only x term. All the numbers added together is going to equal 585. It's going to equal 720. Now we can minus 585 from both sides. They'll cancel out. We're left with 3x equals 135. Divide both sides by 3. So x is going to equal 45. Let's have a look at one more. So we've got a set of parallel lines. The line going from here to here, here to here. We know this is 70 degrees in there. We know it's 160 degrees here. We want to find the value of A, which is over here. So we know these are parallel. And let's label this end big A, this corner here B, this one here C, this one here D, this one here E, this can be F, this can be G. So to do a question like this where we have a parallel lines with, if you like, a bent transversal, we actually need to construct a parallel line going through the bend. So we're going to construct a parallel line there. We might call this H at the end here. Now we can say, let's have a look. We've got a 70-degree angle here, and that's alternate with just this little part here. So the first thing we want to say is that angle BCH, which is the one here, is going to equal 70 degrees because alternate angles are equal on parallel lines. So that gives us part of the angle A, but not the full thing. Now, if we look here, we've got two parallel lines and a transversal, and we've got two angles inside, which means we have co-interior angles. So we can say that angle HCD equals 20 degrees because co-interior angles sum to 180 degrees. So if the other one's 160, the other one has to be 20. And now we definitely know the value of A because we can just add those together. So we can say A equals 70 plus 20, which is 90 degrees.